Okay, so for this example, we are going to talk about some of the features of the graph of a trigonometric function and also how to solve a trigonometric equation. So let's say, for example, for this one, the given trigonometric function is fx equals to 2 cosine x plus 1. And we are given the domain from negative 360 degrees to 360 degrees. So for part A, we are going to write down the period of this trigonometric function fx. So as for applications and interpretation students, we can try to plot this graph into our GDC before we try to solve the following question. So there are some hints when we are going to make a sketch in our GDC. As we are given the domain from negative 360 degrees to positive 360 degrees, this one would be the hint of setting the window. Say for example, negative 360 degrees would be the value of x minimum, and positive 360 degrees would be the value of x maximum. And similarly, we can try to set the range of the y values, that is y minimum and also y maximum. For this simple trigonometric function, we can try to set like y minimum to be negative 2 and also y maximum would be 4. Of course, you can try to use other positive numbers. And then when we are going to sketch this trigonometric function, we have to go to the graphical function and we are going to consider y1 to be 2 cosine x plus 1. And also make sure that during this calculation, the mode of the GDC must be in degrees. So after we successfully inputted the correct function into our GDC, then we can see that the left-hand side would be the rough sketching of the corresponding graph of the trigonometric function. So based on the sketch, we can see that the graph tries to repeat itself for 2 times from negative 360 degrees to positive 360 degrees. And also, we can discover the maximum value and the minimum value of y respectively. So we can try to have a look one by one. So for part A, we are going to write down the period of the function fx. So from the sketch of the GDC, we can see that the graph tries to repeat itself for 2 times, from negative 360 degrees to positive 360 degrees. If we try to observe the graph carefully, we can see that the horizontal distance from negative 360 degrees to positive 360 degrees would be 720 degrees. So based on this information, we can see that for 720 degrees, the graph tries to repeat itself for 2 times. That means on average, the graph will try to repeat itself once for every 360 degrees. So in this situation, we can conclude that the period of this trigonometric function fx would be 360 degrees. And then in part B, we are going to find the maximum value of this trigonometric function fx. So as we are allowed to use the GDC to sketch the graph, then we can try to use the function in the GDC, that is, the function to find the maximum point of a function. For example, if we are using TI-84 plus GDC, we can try to use the function second, trace, and then choose the 4th option. That is the function to find the maximum value of a function. Another suggestion is to consider the maximum value of the single cosine function. So for the basic cosine function, we know that cosine function lies between negative 1 and 1. That means the maximum value of the single cosine function would be positive 1. Then in this situation, we can try to consider replacing cosine x by 1. That is to consider the case when cosine x attains its maximum. Then we can try to replace cosine x by positive 1 so that the result will be 2 times 1 plus 1. That means 2 plus 1 and the maximum value will be positive 3. In part C, we are going to solve the equation fx equals to negative 1. That means solve the equation 2 cosine x plus 1 equals to negative 1. So firstly, we can try to set up the equation 2 cosine x plus 1 equals to negative 1. As we have one number on the right hand side, my suggestion is to move negative 1 to the left. such that it becomes 2 cosine x plus 2 equals to 0. Then we can try to consider the left-hand side, 2 cosine x plus 2. And in order to solve this, one of the methods is to use the GDC, such that we can try to delete the previous function, and then we consider this one to be y1. And then we can copy this to our GDC. So as for part C, we are going to solve an equation which is equivalent to finding the horizontal intercept, finding the x-intercept in the graphical function. Then we can try to have a look at the setting of the window. So for this question, we are still considering the values of x from negative 360 degrees to positive 360 degrees. That means we don't have to change the x minimum and the x maximum. One of the hints is, as we are going to find the x-intercept only, we can try to adjust the range of values of y. So every time when we are going to solve an equation by using the GDC to find the horizontal intercept, the x-intercept, then we can try to set the y minimum to be -1 and also set up the y maximum to be +1, so that the range of values of y would be narrower, and that would be more convenient for us to get the x-intercept. Then in this situation, we can see that for this range of values of x, we have 2 x-intercepts in total. That would be -180 degrees and also 180 degrees.